So this is day 3 of factoring and solving. We're actually going to talk about the solving part. Notice up to this point, we've talked about basic factoring, we talked about California method, we talked about special factoring, like if it's a difference of squares or a perfect square trinomial. Today we're actually going to talk about the solving part. What does it mean to solve one of these? So whenever you're starting, notice you're going to have the question in standard form. And if I'm talking about standard form, remember standard form is y is equal to ax squared plus bx plus c. And what I want to do at this point is I want to get it into intercept form. Intercept form, if you recall, is y is equal to a x minus p x minus q. And the whole idea of intercept form is using what's called the zero product property. And the zero product property says this: zero product property. And it says if I have two things, usually separated by parentheses, and these two things are multiplied together and they equal 0, that means that either spot is equal to 0. That means I'm going to set them both equal to 0 and solve. Let's see how this works. So, first of all, letter A. Letter A is starting off with this. So letter A is in standard form like we talked about, y equals ax squared plus bx plus c. What I want to do is I want to factor this into intercept form. So the first thing I have to ask, is there something I can factor out of x squared plus 3x minus 18? Notice for it to be in standard form, for this to work, as for the zero product property, it has to equal 0. There is nothing I can factor out. It does equal 0. So at this point, I just want to factor it. Since a is equal to 1, I'm going to go ahead and I'm going to use basic factoring. So basic factoring says what multiplies to be negative 18 and adds to be 3. So my factors are 1 and 18, 2 and 9, 3 and 6. If I look at these, 1 and 18 is not going to give me 3, 2 and 9 is not going to give me 3, but negative 3 and positive 6 will give me positive 3. So that tells me I'm going to have x plus 3 and x, that tells me that x minus 3, x plus 6 is going to be my factors. But what's different than what we've been doing is it's still equal to 0. At this point, I have to use the zero product property. The zero product property tells me that either of these is equal to 0. So I have to find the possibilities for x. So I'm going to say that x minus 3 is equal to 0, or x plus 6 is equal to 0. At this point, I just need to solve them both for x. So x minus 3 is equal to 0. I'm going to add 3 to both sides. So x is equal to 3. Or x plus 6 is equal to 0. I'm going to subtract 6 from both sides. So x is going to equal to negative 6. Notice I come up with two possible answers. And I want both of those answers because both of those are a possibility. How does this work? Am I sure this is going to be a correct answer? Let's go ahead and check. So I bring up my handy-dandy calculator. I go back to my original equation. My original equation was x squared plus 3x minus 18 equals 0. Let's check this. I'm going to say that x is 3. So I'm saying 3 squared plus 3 times 3 minus 18. Notice that gives me 0, just like it's supposed to. X squared plus 3x minus 18 gives me 0. Let's check my other problem. My other problem says negative 6 squared plus 3 times negative 6 minus 18. This again gives me 0. So I now know that both of these are good answers, and I've checked my work using my calculator. Okay, so there's my answer. Let's try another example. Letter B, solve 2t squared minus 17t plus 45 equals 3t minus 5. For this to work, you need to remember that I have to first get it into standard form first. Is it in standard form where it equals 0? The answer is no. So let me go ahead and get this so it equals 0. I'm going to subtract 3t from both sides. So I get 2t squared minus 20t plus 45 is equal to negative 5. I'm going to go ahead and add the 5. So I get 2t squared minus 20t plus 50 is equal to 0. Notice it's now equal to 0 in standard form, so it equals 0. The next thing that I want to make sure is I want to make sure that the a term, the squared term, which are the same thing, is positive. It works out so much nicer if a is a positive number, not a negative number. If it's a negative number, go ahead and divide everything by a negative 1. And since I'm dividing by 0 by a negative 1, it's just going to work out so it's positive. So I'm going to make sure that my a term, my squared term, is positive. At this point, what I want to do is I want to ask, is there something I can factor out? Notice I can factor out a 2. And I end up with t squared minus 10t plus 25 is equal to 0. At this point, let's go ahead and factor this. There's different ways I can factor this, but notice t is a perfect square. 5 is a perfect square. 2 times 5 times t is 10. So notice this is t minus 5. T minus 5 is equal to 0. Notice I can at this point set each equal to 0. 2 is equal to 0. T minus 5 is equal to 0. Or t minus 5 is equal to 0. I know 2 is not equal to 0, so I can just ignore that. T minus 5 equals 0. I add 5 to both sides, so t is equal to 5. Again, I add 5 to both sides, and t is equal to 5. So what does this mean? I don't get it. Well, if I was to look at my actual graph of this, what this is actually telling me is I have what's called a double root. I'm actually found, 1, 2, 3, 4, 5. I've actually found my vertex point. Whenever I'm finding these answers, I'm actually finding my x-intercepts. My roots is another name for this. And this is called a double root. Whenever I get an answer that repeats itself, t equals 5, t equals 5, it's called a double root because I'm actually finding the vertex. So my one answer is just one of these, t equals 5. Let's go ahead and let's check this. So to check this, I'm going to go ahead and start with my original equation. And I'm going to say 2. Well, I'm not going to start with the original equation. I'm going to start up here in red where it says 2t squared minus 20t plus 50. That's what I'm going to check. I can go 2 times 5 squared minus 20 times 5 plus 50. And notice this is going to give me 0. It solves my problem. I know this is my check, and it worked out. Let's try a different problem. This is where we were at. I kind of paused and came back to this. Let's try a different problem. What if I gave you a problem that looks like this? Solve negative 20x squared plus 40x equals 0. Well, again, remember what this is telling me. It's negative, so this is going to be facing down. The first thing I want to do every time is I want to set this equal to 0. I've done this, but then I want to factor. Notice I can go ahead and factor out a negative 20x. And that's going to leave me with x minus 2 is equal to 0. Again, the negative 20, I didn't do this on the last problem, but if I divided this by negative 20 to both sides, the negative 20s will cancel. I get x times x minus 2. 0 divided by anything is still 0. So notice those negative 20s cancel out and they go away. I have x times x minus 2 is equal to 0. Again, I use the zero product property and say x is equal to 0 or x minus 2 is equal to 0. If I go ahead and add 2 to both sides here, x is equal to 2 or, as I already have, x is equal to 0. What does the graph of this look like? Again, I'm finding my intercepts. I'm finding what's called my roots. And my graph of this is going to go through 0, 0, and then come back down. Ooh, that's an ugly picture. Let's try that again. So it's going to go up. Since it's facing down, it's going to go up through 0, 0, and then back down at 2. And that's what my graph looks like. Those are my 2 zeros. So those are my 2 answers, my 2 solutions, x equals 0 or x equals 2. Again, I can go back to my handy-dandy little calculator, and I can check this. I can say negative 20 times 0 squared plus 40 times 0. Well, they're both going to be 0, but notice it gives me 0 as my answer. At the same time, I'm going to bring up my last equation, and I'm going to back up. I brought up that last equation by hitting second enter, and it brings up what I last typed. Notice it gave me the exact same thing, and instead of plugging in 0, I'm now going to plug in my other answer 2. And I'm going to plug in my other answer 2 here. And if I hit enter again, it gives me 0. So again, with my calculator, I'm able to check that these are my 2 zeros, my 2 roots, my 2 x-intercepts. These 3 words, these 3 phrases are interchangeable. They all mean the same thing. They're what x needs to be so that my equation equals 0. Let's go ahead and try another example. That's not the example I want. That's the example I want. Let's try this one. So, solve 121x squared minus 49 equals 0. Let's look at this. Again, this on my left side is a binomial, two terms. Since it has two terms, I want to see if this is a difference of two squares. Notice 121x squared minus 49. Yes, 121x squared is a perfect square. What? It's 11x squared. 49 is a perfect square. What? 7 squared. So notice it's 11x plus 7, 11x minus 7. And again, this equals 0. I have my two factors. By the zero product property, I can say 11x plus 7 is equal to 0, or 11x minus 7 is equal to 0. I want to go ahead and solve these two for x. So here I'm going to subtract 7, 11x is equal to negative 7, divide by 11, x is equal to negative 7 over 11. Or, I can go to the other side and I can add 7, 11x is equal to 7, divide by 11, x is equal to 7 elevenths. Two answers. Again, I can pull up my handy-dandy little calculator. Ignore that bell. And I'm going to go ahead and check this. So I'm going to say 121 times negative 7 divided by 11 squared minus 49. It gives me 0. I'm going to hit second enter to bring up my entry again. Instead of negative 7 elevenths, this time I want positive 7 elevenths. So I'm just going to get rid of this negative. I'm going to solve this problem. And again, it gives me 0. And so there are my two answers checked. Let's try that problem that I brought up accidentally. Let's try this one. 16x squared minus 24x plus 9. I could definitely use California method on this, but it's also nicer to notice that 16x squared is a perfect square. What? 4x. 9 is a perfect square. What? 3. 4 times 3 is 12 times 2 is 24. So notice it fits the pattern of 2AB. So I can say this is 4x minus 3 times 4x minus 3, and that's equal to 0 because this is a perfect square trinomial. Notice these two are identical, so I can go ahead and say 4x minus 3 is equal to 0, or 4x minus 3 is equal to 0, and I can just go ahead and solve this. I'm going to add 3 to both sides and get 4x is equal to 3. I'm going to divide by 4 and get x is equal to 3/4. Do I need to do this twice? No, but what do I know? I know that this is a double root. That means it happens twice. That means that this is actually part of my vertex. The vertex is actually hitting the x-axis. My root, my x-intercept, and my 0, all the same three phrases, are all at 3/4. Let's check this. Again, I bring up my handy-dandy little calculator, and I'm going to go ahead and say 16 times 3 divided by 4. I want that part to be squared. I want to subtract 24 times 3 divided by 4. And I want to take that and add 9. And if I work this out, I get my solution of 0. So it works. I can check it. My answer is there, and it makes sense. That's the second day of notes. That's the third day of solving and factoring. Hopefully this makes sense to you. We will talk more about this. I'm confused on which day this is, so this is probably the notes that you're going to see for Friday. So we'll talk about more of this in class on Friday. Have a great day. We will get the homework in class. Have a good day.